Welcome to section 7.3, Parabolas. So far, we have talked about parabolas, but in this case, with parabolas being a conic section, we are going to define them in terms of distance. In your book, they call this definition 7.3. We are going to be learning about the relationship on a parabola between its vertex, something that we know, and two new ideas, distance related, about a parabola. One labeled F, it's called the focus, and the other one is a line. It's either horizontal or vertical, depending on how our parabola is. This line does not intersect with the parabola. This line is called the directrix. So in order to define a parabola in terms of distance, every single one of these infinite points on this parabola is equidistant from both the focus, F, and the directrix, D. So if you take a look at, let's say, this point all the way up here on our parabola, this distance right here from this point to the focus is the same distance as its distance to the line called the directrix. We will be taking a look at vertical parabolas, parabolas that open up or down. So we have the standard equation of a vertical parabola here, and I will open this back up when we take a look at it as well. But when we have this, our parentheses with x in it is squared, and it equals 1 with y. The coefficient out front over here, if it's positive, we have our parabola opening upward, and if it's negative, opening downward. Then we can also have what's called a horizontal parabola, which opens either left or right. This looks extremely similar, except it's our y that ends up being squared. And once again, if this coefficient out front here, 4p or just p, if it's positive, our parabola opens right, and if it's negative, our parabola opens to the left. Every single time, no matter which type of parabola we have, hk is our vertex. This is similar to how we dealt with circles, where hk was the center. The other thing that's similar is that our focal length is p. It's the absolute value of p because p can sometimes be negative, and in order to be length, it does have to be a positive value. Let's understand all of these variables a little bit better. We found that we have 4 different ways we can draw a parabola: opening up or opening down, those are called vertical, and then opening to the right and opening to the left. So I will do one where we open up, and I'll also do one where we open to the right. They're very similar. Once you understand how it opens up, you could very easily label opening down as well. But we know that the vertex, that's something we've talked about before. The vertex is like the turning point of the parabola. In this case, it is the absolute minimum point of this parabola because it opens upward. So this is our vertex, hk. Then our focal length, which is the absolute value of p, which we'll be finding from an equation shortly, that is the distance from the vertex to the focus. The focus is inside the parabola. So our focus, we will label in gray as F, and I'll be sure that I label this vertex as V. So the distance from our vertex to our focus is called our focal length, and that is this length right here. That is P. Then our directrix, horizontal line in this case, and the directrix would be down here. We'll call that D for directrix. The distance from the vertex to the directrix is also P. So this length is P, and this length is also P. That is called the focal length. This last part here, written in blue, is talking about the focal diameter. That is telling us how wide across our parabola is at where the focus is. So it's how wide across our parabola is here, crossing through the focus. That length is 4p. So making our focal diameter, that would be this length right here, all the way through our focus. So this whole thing, this length, is 4p. Again, it's a length, that's why we have these things in absolute value in case p is actually a negative number. This line right here, this line segment, is actually called the latus rectum. Let's see what this would look like if we no longer had a vertical parabola, but rather a horizontal one. If we turned our parabola this way, we now have the exact same situation. We have a side-facing parabola, Our vertex is no longer an absolute minimum or maximum. Our vertex is just the leftmost point in this case. We have still a focus and still a directrix, but now our directrix is actually a vertical line. Our focal lengths, P, are still the same, the length from vertex to directrix and the length from vertex to focus. They're the same length, as well as the focal diameter, which tells us the width of our parabola passing through the focus. This line segment right here, again, is called the latus rectum. Understanding how to find the vertex, the coordinates of the focus, and the equation of the directrix will allow us to sketch our parabola. Here in example 1, we see that we have the equation of a parabola. Now, parabolas and circles look pretty similar in that they both have parentheses, one with an x in it, one with a y in it. However, parabolas are different from circles in that they're both not squared. Circles, they both would be squared. In parabolas, only one of them is squared. If the one with the x in it is squared, it means we have a vertical parabola, as we can see here. So this is the standard equation of a vertical parabola because x minus h is the factor that is squared. Then we have a 4p out in front, and then we have y minus k. So the first thing that we want to do is identify our vertex, focus, and directrix. Let's first look at the vertex. The vertex is the hk. So it's hk. So in this case, our h, and in all cases, h is with the x value and k is with the y value. Because the subtraction signs are built into the equation or the formula, we take the opposite here. This is really x minus negative 2. So our h value is negative 2. Then if we take a look by our y, we have y minus 1. So our k value is just positive 1. So our vertex is at the coordinate point negative 2, 1. Next, we want to look and find the focus. The way that we find the focus is we look at the focal length. So the focal length is P, and that will help us both find the focus and the directrix. The way that we can do this in the easiest way is to actually start sketching. So we do need to know if our parabola opens up or opens down. We can see here our 4P is negative 12. So our P value, you could see here, would be negative 3. And if P is positive, it opens up, and if P is negative, we open down. Since we're negative here, our parabola is going to open downwards. Let's start by plotting our vertex. Our vertex is at the coordinate point negative 2, 1. And I'll label that V. Then, since we know we open downwards because this coefficient here is negative and P is negative, we know that we are going to be going something like this, going down. So we know that this V is a maximum. That means that our focus is going to be down here beneath it, inside the parabola, and our directrix, our line, in this case a horizontal line, is going to be up top here. In order to find where to put those things, we need to figure out what the focal length P is. Well, since 4P is this number out front, we know that 4P equals negative 12, the number out front. To solve for P, we'll have that P equals negative 3. So since P is negative, we know we open downwards. We've established that. The absolute value of P to be a focal length is 3. So our focal length is 3. The focal length is the distance from the vertex to the directrix and the vertex to the focus. So let's first graph our directrix. That means we're going 3 units above the vertex. So our directrix, I'll graph in blue, 1, 2, 3 units above the vertex, and it's going to be up here. We'll label it D for directrix. Then our focus, which I'll do in pink here, is 3 units beneath the vertex. 1, 2, 3, and it's here. And we'll label it F for focus. Now, how can we graph even more points? I know that the vertex is going to go down here, but is it like a skinny parabola? Is it pretty wide? We need to figure that out. And the way we can figure that out is by the focal diameter. How wide the parabola is through the focus here. The way that we figure that out is that is 4P. It's actually the absolute value of 4P since it's a length. So 4P is negative 12. So the absolute value of 4p is positive 12. That means that it's positive 12 through here. So it's 6 units left and 6 units right. Let's find those 2 points. So if we go 6 units to the left here, 1, 2, 3, 4, 5, 6, and then 6 units to the right of the focus, we're right here, and we can sketch our parabola knowing those 2 extra points. Now we do need to find what the actual focus is and the equation of the directrix. We can do that. Our focus is at a coordinate point. It's directly beneath the vertex, so it's going to have the same x coordinate, but it's at -2, -2, since it's 3 units below. So you could have just looked at the vertex and saw 3 units directly below it, with the y-coordinate would be -2. In a similar way, our directrix is 3 units above here, and it's a horizontal line, so it is of the equation y equals, and it's 3 units above where the y-coordinate is 1, so 1 plus 3 is 4. You could also just count, that's where we're at. The directrix is the line y equals 4. Just to add one quick extra thing here, something that I already talked about, but I wanted to just kind of draw in here. This entire length is 4p. So this is 12. And it's the absolute value of 4p in case that value is negative. But that is essentially just this value out front here. That is called the focal diameter, and it's the length of what's called the latus rectum, the width of the parabola through the focus. That allowed us to find 2 extra points on our parabola so we could graph it. Here we just have another example similar to the first one, except our only difference here is that this value out front here, this coefficient, is positive. That means that this parabola is going to be opening up. We know that this is a vertical parabola because the variable that is squared is the x. So we're going to have a parabola opening up. The first thing we want to do is find the vertex. It's probably the simplest thing. So the vertex, remember, is h, k, and it's the opposite of what's in there. So our vertex in this case is +1, -4. We also know that because this is positive in here, since that's positive, put a little plus, we know that our parabola opens up. Okay, so we know that we have a parabola opening up because not only is this value positive, but it is a vertical parabola because the x-coordinate is squared. So let's start by sketching what we know so far, and then we can figure out our p-values where our focus and directrix are. So we have plotted our vertex, and we know that our parabola opens up. The next thing we need to do is identify the focal length. The focal length will allow us to find the distance or the length between our vertex and the focus, which will be above it in this case since the focus is inside the parabola. And then it also tells us the length, the focal length also tells us the length between the vertex and the directrix. So our directrix is going to be, again, a horizontal line, but this time beneath our parabola, since our parabola opens up. So let's find that focal length. In order to find the focal length, we take a look at our 6, because we know that that's 4p, and the focal length is p. So 4p equals 6 in this case. So p is 6 over 4, which is 3 over 2. So p is 3 over 2, which is 1.5 units. So since our focal length is 1.5, we can count 1.5 units up to find the focus. So our focus is 1.5 units above the vertex in this case. So it has the same x-coordinate of 1, but the y-coordinate is 1.5 units higher than -4. So it's going to be -2.5, or you can write it as -5 over 2. Either way is fine. This focal length also gave us the length between the vertex and the directrix. So our directrix is actually 3/2 units below the vertex, or 1.5 units below, and 1.5 units below would make the directrix down. If this is at -4, going 1.5 units below that would be -5.5, or at -11/2. So we're down here. So our directrix is the horizontal line y equals negative 11 halves or negative 5.5, either way. Now, the last thing that we want to do to sketch this is to figure out how wide our parabola is going to be. We know our parabola opens up, but is it a wide parabola? Is it a narrow parabola? The way that we can figure that out is we can figure out the focal diameter, the width of the parabola through the focus. The focal diameter is 4p, or the absolute value of 4p, since it's a length. By the definition, we know that 4p is just this number out front. It is 6. 6 is the focal diameter. Since 6 is the entire diameter across, or length across, we know that we can count 3 units to the left and also 3 units to the right at our focus. So if we count 3 units to the left of our focus, we'll be at 1, 2, 3 over here at negative 2, comma, negative 5 halves, and we'll be 3 units to the right at 4, comma, negative 5 halves. Then I know that those 2 coordinate points are on our parabola, so we can simply sketch from there. And we have the nice width of our parabola. Again, this right here is 6 units. That is the focal diameter. It's the length of the latus rectum. In example number 3, it looks so similar, but we really do have a little difference here. We now have our y coming first, and our y parentheses here, the factor that y is inside is actually squared, and the one that x is inside isn't. That means that this is a parabola that opens up either left or right. This is called a horizontal parabola. Now, if this coefficient out here is positive, it means that our parabola opens to the right, and if this number were negative, it would mean that our parabola opens to the left. In this case, our parabola will open to the right. We find our vertex first in a very similar way. Now be careful, it still goes xy. So we do still need to first look at this value here with the x and then this value here with the y. So our vertex in a similar fashion is negative 1, comma 2. The next thing I want to do is write out that this parabola is going to be opening right because our p-value is positive, the number out front. Now what is that exact p-value, the focal length? The way that we find that out is we take 4p, the value out front, and set it equal to our value 8, which is out front. So p is 2. No need for absolute value, it's already positive. Our focal length is 2. We have plotted our vertex. We know that our focal length is 2 and that our parabola opens to the right. Therefore, we know that our focus, since it's inside the parabola, is to the right of the parabola. Our focal length is 2, meaning that the distance between the vertex and the focus is only 2 units, so they're not far away. We know that that means our focus is right here. Our focus is 2 units to the right of the vertex, meaning its x-coordinate is 2 units to the right, so it moves from negative 1 to 1, and the y-coordinate is the same. So our focus is at the coordinate point 1, comma 2. In a similar way, our directrix is 2 units to the left of the vertex. In this case, our directrix is going to be a vertical line because we have a horizontal parabola. And so our directrix, since it's a vertical line, is of the form x equals, and we are at x equals negative 3, since we're 2 units to the left of the vertex, which has an x coordinate of negative 1. So our directrix is the vertical line with the equation x equals negative 3. The last thing we want to do is figure out how to sketch our parabola. Is it narrow, wide, what does it look like? We need to figure out the focal diameter, the length or the width of the parabola, rather, through the focus. Our focal diameter is the absolute value of 4p. Remember that 4p is just this value out front. It's 8. So our focal diameter is 8. That means since this entire width here of the parabola needs to be 8 and the focus is right in the center, we go 4 units up, mark, and 4 units down and mark, and then we have 2 other coordinate points on our parabola to sketch it. So we have found that our focal diameter is 8, and that allowed us to find 2 other points on our parabola so we could sketch our parabola that opens to the right. Example 4 looks a little bit different. We do have an equation of a parabola, but it is not in standard form. In order to put it into standard form, we need to complete the square. Now this looks slightly different than a circle because with a circle, both the x squared and the y squared terms stayed all on the left, and any constant we had stayed on the right. With parabolas, we see that whatever variable, x or y, is squared is on the left, and all the other things, or the other variable, goes to the right. So in this case, it looks like the variable that's squared is y, so everything with y in it is going to stay on the left. So we'll have y squared plus 4y, and then we'll leave a space to complete the square. And then we'll move that 8x over to the right-hand side, so it's negative, and we still have that 4. So completing the square, we need to make sure that our a value here is 1, which it is. We take half of our b value, so we get 2, and then we square it. So we'll get 4. So I'm going to be adding 4 to both sides. Then we've created a perfect square trinomial. This trinomial right here factors into y plus half of that b value, the value we squared, so y plus 2 quantity squared, equals, now on the right-hand side, I can clean this up a little bit. We'll have negative 8x plus 8. I do still want to factor out the GCF on the right-hand side. The GCF over here is going to end up being negative 8, since I want to take a negative out. And we'll have x plus 1 remaining. So here we go. We have the equation of a parabola in standard form. From here, we're going to do what we've been doing in the other examples. This is a horizontal parabola, meaning it opens left or right, because the term with y is squared. Now we see that this one actually opens left because this coefficient here, the p-value that we'll end up finding, is negative. So the first thing we want to do is find our vertex. Our vertex is hk, so our vertex is going to be negative 1, negative 2. We already determined that since our p-value is negative and this is a horizontal parabola, our parabola is going to open to the left. Now, the next thing we want to do is find our p-value. We know that 4p equals negative 8. That means p is negative 2, and our focal length is the absolute value of p, which is 2. Remember, the focal length tells us the distance between the vertex and the focus, and also the distance between the vertex and the directrix. Since we have all this all ready to go, we can begin by graphing. Here is our vertex. We know that we open to the left, so we know that our focus is going to be to the left of the vertex 2 units. So our focus is 2 units to the left here, and then our directrix is 2 units to the right, and is this vertical line here. So let's label those. Our directrix is a vertical line, so it has the equation x equals, and in this case it's x equals 1. We already found our vertex over here, and our focus is just another coordinate point. Our focus is 2 units to the right of the vertex, or to the left rather, of the vertex, so it is the coordinate point negative 3, negative 2. The last thing that we need to know is sort of how wide or narrow to graph or to make our parabola, and we can do so by figuring out the focal diameter, the width of the parabola through the focus. The focal diameter is the absolute value of 4p. Well, we know that 4p is negative 8, so the absolute value of that, since it's a length or a distance, is 8. So the focal diameter is 8 here, meaning we can sketch 4 units up and 4 units down, since it is symmetrical about the focus. So we'll go 4 units up from the focus and 4 units beneath it, and those are 2 other coordinate points on our parabola. In this video, we took a look at parabolas in a more distance approach, and we analyzed them with different distances, such as focal length and focal diameter, in order to sketch a parabola in a different way.